So we will be discussing about surface area of cube and prism. Right, let's start. So before we deal with surface area, let's discuss some basic concepts of three-dimensional objects or solids. So if you say a certain figure is a three-dimensional object or figure, therefore you're saying that it is a solid. So here, a plane is a two-dimensional flat surface. So you have been learning about this to find certain area or perimeter. Actually, you're dealing with plane that extends in all directions. There are two different ways that planes may be related in space, right? So there's different ways. So first is intersecting in a line. So these two planes, plane P and plane Q, intersect at line L. Okay, there is an intersecting line. Also here, intersect in a point. So line Q, plane Q, plane P, and plane A intersect in three different points. Alright, so we also have another one, no intersection. These are called parallel planes. Intersecting planes also form three-dimensional figures or solids. A polyhedron is a solid with flat surfaces that are polygons. There are different parts of polygons that you need to understand better. So an edge is where two planes intersect in a line. So here, for example, this line here is called, this is an edge. Why did we say that is an edge? Because it is the intersection of two planes. Alright, so I'm going to highlight now the two planes that intersect at that certain line. So this is the first plane, alright? And the other one is the one at the back with the broken side, because it's not actually seen with this view. When we say vertex, it is a point of connection, okay? Like this one is a vertex. This is the point of intersection of three or more planes, all right? So let's identify the three planes that intersect in this point. So this is the first plane, all right? Because that's the one connection of that. This is the second plane. And the third is this one, the one in the bottom or the base. The other term that you need to understand is a face. Remember, dealing with nets of a certain figure or a certain solid, if we try to cut a certain box and you see that it's already lined up in a plane, you would see that it is composed of different figures or different planes. Those are actually called faces, right? All right. So a face is a flat surface. So in this one, there are a lot of faces here. This is a face here, right? And this is also a face and more parts of here. As long as it is a flat surface, that's a face. Okay. So let's identify what is a base. Right? So bases for prism and pyramid. For prism, the two parallel, this is the thing that you have to take note. When it's a prism, there's two parallel congruent faces. Okay? And pyramid. Because some people, they get confused of the difference between and the similarities between prism and pyramid. Alright? When you talk about prism, you're actually talking about a certain figure with two bases and they are parallel. Meaning to say, if you extend them, they will not intersect at a certain point. And then there is a pyramid. A pyramid has only one base, right? So there's more pyramid. It could also be a triangle. So there's a lot of types of pyramid. Let us now go and discuss how to identify parts. So we have here a certain solid. It's a rectangular prism. I will be giving you some examples of its base, faces, edges, and vertices. Let's start with base, right? So when we talk about the base, you're actually talking about this part, okay? The top and the bottom part of your figure. So this is your base, also the bottom one. Okay, we used broken lines here because those are the view you cannot see, but those are imaginary lines, meaning to say they actually exist The back part exists. Alright, so these are the two bases. How do we name this base? We're going to name it using the four vertices, the four letters. So here is the name of the bases. So we have rectangle AB, CD. You can actually switch the letters as long as they are consecutive. So you cannot say BDCA. They should be consecutive or in order. ABCD, CDAB, that means the same base. Also the base in the bottom, so you have GHEF. Alright, so base is GHEF. Okay, let us identify the vertices. There's actually a lot of vertices here. Alright, so you have point A as one of the vertex, point B, point C, point D, point E, right? Point F, point H, and then point G. Okay, so these are all the vertices, the connection of three planes. Next, let's go and have some faces. So a flat surface is a face. So this part is a face. So you just have to make sure that, okay, so this is a face. This is actually a face right here. You're going to use again the four letters. So you have rectangle, D, C, E, F. Always write it in order. There's a lot of faces here, so I'm just going to pick two. This is also a face. So A, D, F, G. So rectangle A, D, F, G. Alright, let's go and talk about edges. So edges are like the corners. It's like a line. So this is an edge. So AD is an edge, right? And then there's more, like AG is also an edge. Then HE is also an edge. And more, alright? That's not just it. There's a lot of that you have. So let's now go and discuss. We identified different parts of a certain solid now. Let's go and deal with surface area, right? So what is a surface area? A surface area of a three-dimensional figure with plane faces is the sum of the areas of the faces. Okay, the surface area of a solid will equal the area of the net which forms it is. It is thus often helpful to draw the net first. Okay, so before I have discussed what a net is, let's take a look on some of the examples of a net. So here, as you can see, this is an example of a rectangular prism, and then it's cut. And you would see like it's a box that you open it. This is actually the net. This is the net of our... So this is the net of our rectangular prism. You would see that this is the front, the bottom, the back, top, and side and side. Okay, so it became a 2D shaped figure. So what we're saying when we're talking about surface area, you're actually adding all the areas of this figure. You have to check. It's like computing for an area of a composite figure. You have to deal what are the figures that you see, and then find its area, and then add them all. Right? So let's go back to our PowerPoint. So here, you will understand it much better. Actually, we're only going to focus with cube and all prisms. And I'm going to give you the formula. If you don't know the formula, you just have to take note what are the areas of each faces. Right? Compute the area of the faces and then add them all. Alright? So here, for example, we have different types of cubes. So these are the different example of a cube. So as you can see, this is an example of a cube. Alright? So it's a 3D shaped. Right? So the ones that you can see in the front are not just it. There's more at the back of all the cubes that you have. Right? So this is a dice. We have some wooden block and more. Right? So let's now go and understand the formula for the cube. Right? So the formula for the cube is surface area is equal to 6 times s squared. So what does that mean? So that only means that you just have to find the square first of the side, then multiply it by 6 because all its sides are actually equal. So for example, for the first cube here, this is the first cube. So if you want to find the surface area of our cube here, surface area is equal to 6s squared. So the side is equal to 5 centimeters. Therefore, what you do, you would write 6 multiplied to 5 and then square. You have to be careful when you're doing this. You cannot multiply 6 and 5 first, but square 5, the first method. So 5 squared is actually 25, right? And then multiply it by 6, okay? So 25 times 6 is actually equal to 150, right? So 4 25s is 100. Therefore, if there's 6 of them, so the other two would be 50, so 150. And don't forget the unit, it should be cm squared, right? So that's the first method that you need to take note and you have to remember. Let's go and try another one. This is the surface area. What about if it's a fraction? So what you do, still the same thing, surface area is equal to 6 times your value of side, which is 2 and 1/2. And make sure to square it, not raised to 5. So it should be squared. Right, so 6. And then this fraction could be written as 5/2, right? Because 2 times 2 is 4 plus 1 is 5. Then square it. Square first 5 over 2. So you know 5 over 2 times 5 over 2 is equal to 25 over 4. So you have 6 times 25 over 4. Right? Next method, we can do cancellation. So this can be crossed out. They can both be divided by 2. So this will be 3 and this will be 2. So therefore, this is equal to 75 over 2. And you can make that as a mixed number. Alright? And don't forget your unit, which is inches. And then square it. Square inches. Okay? So those are our first solutions or given. So that's how we find the value for the cube. Now, what about prism? Right? So let us check first the definition of a prism. So here we have the definition of the prism. Prism is a solid object with identical ends, meaning to say whatever end you have here or the base, it's also the same thing at the end. Alright? Then they have flat surfaces, it couldn't be curved, and the same cross section. What is a cross section? A cross section is when you slice it or cut it, it should be the same figure. So remember, if I cut this, you will be getting the same figure. So here, for example, this triangular prism here, it has, as you can see, a cross section is the shape made by cutting straight across on the object. The cross section of this object is a triangle, right? It has the same cross section along its length. So you have to cut it here in this part. Okay, so it's a triangular prism, right? So there's more that you have to take note. A prism doesn't have any curve, so a cylinder is not actually a prism. Bases should be identical, it should be the same. Sides should be parallel, right? These are all prism. Square prism. Cross section is a square. Cube is actually a prism also. Then we have a triangular prism. Is a we have pentagonal prism. The cross section is a pentagon. So there's more of the prisms and more things that you have to learn about prism. But the most important one that you have to take note if you're dealing with prism is that it should be identical ends, flat surfaces, and the same cross section. Okay, so when you cut it, it should all be the same figure. Alright, let's continue. See, here are the different examples of prism. Okay, so this is a triangular prism. So as you can see, right? So in what way can we have a cross section here, right? So as you can see, the cross section can be on this side, all right? So this can be cut. You can cut this in this part, right? So in this part, you can cut it, right? And be getting the same figure. So therefore, these are our bottom or our bases. So same thing here, you can cut it on this side and we'll get the same thing. So this is a cross section. So here, you can cut this and you'll be getting the same figure. Well, the other one here, it should be cut on this part so that you get the same figure. While a Toblerone box is an exact example of a rectangular prism. A triangular prism. Alright, so let's go and start solving per prism. So for example here, this is a rectangular prism. As you can see, this is manually solved. Why am I saying this is manually solved? It says here two faces of 6 times 4. Okay, this is the this solution is computing for the following faces. This is 6 times 4 and also the top part is also a 6 times 4. And then the 6 times 3 is actually this part. Alright, 6 times 3 is this. And the other one here, this is the 6 times 3. Well, the last one, which is 3 times 4, right? 3 times 4 is this part here. 4 times 3, and this one is also 4 times 3. So this is manually solved. If you take all the areas of the following faces, you will land to 108 square centimeters. Alright? Now, let's try to identify the formula for all types of prism. Right? The surface area of a prism is identified using the formula. 2 times the base area plus base of the perimeter times the length. Okay, we will be using this formula with the other example earlier and check whether we got the same value. We will get the same value. So, please take note of how to identify the base. The base is where you cut your figure and get this, it is where your cross section is located. So, if you cut it on this part, will you be getting the same figure? Yes, therefore, this part here is your base. Okay, that is the cross section. You cannot cut it under and we'll be getting a rectangular base because if you do that, in the bottom, you will not be getting a cross section. So, the base is actually your cross section. Alright? And base perimeter. So, you have to find the perimeter and times the length. Length is also denoted by height. Alright? Let's go and check our prism earlier. So, please take note of the formula. Right? So, this formula, we will be using this for the other solution. Now, let us find the surface area of this given here using our formula. So 2 times, so surface area is equal to 2 times your base area plus base perimeter times the length. Alright, so here we will take this part as our cross section. This is our cross section. So if that is our cross section, therefore this is our base. Okay, so this is our base. So if you cut that, you'll be getting the same figure. Therefore, you would have 2 times your base area. Your base area is 4 times 3, right? That's the formula for rectangle, or a rectangle or a square. This is a rectangle. It has different sides. So, we have 2 times 4 times 3, right? Plus base perimeter, right? Base perimeter. What's the perimeter of this? So, if this is 4, this should also be 4, and this should also be 3. Therefore, our base perimeter is 8 plus 6. Therefore, that's 14. Okay, 14 times your length. Your length is 6. Okay, so you have to be careful in finding the surface area. Therefore, you do the multiplication first before you add them. So, what is 2 times 4 times 8? So, 2 times 4 is 8. Or you do 4 times 3 is 12. Times 2 is 24. Okay, 24 plus what is 14 times 6? So, we have 14 times 6. Right? So, this is 24, 2, and then 6, 7, 8, 84. So, 84. Add them up. What is 24 plus 84? This is 108. And don't forget the unit, it's centimeters. And because it's surface area, it should be squared. Right? So this is the same answer as this one. So always remember this formula. This is now the formula for all types of prism.